Welcome back to part 2 of IP addressing for CCNAs. In part 1 we looked at the format of IP addresses. What we'd like to look at today is how the computers tell the difference between Class A, Class B, Class C and so on addresses. So let's start straight away. It's all very well saying that we're going to have a Class A address and the first 8 bits are going to be considered network and the last 24 bits are host. But how do we tell a computer or a router or a PC or whatever where to draw that network host line? So what was decided to do was to have the most significant bits tell the computer whether it's a Class A, Class B or Class C address. So what they decided to do was to say, okay, if there is a 0 in the very first bit position, so as the computer reads the address, the very first bit is a 0, the computer can say, aha, I get this. This is a Class A address. Therefore, the first 8 bits should be considered network, and the last 24 bits should be considered host. So as it reads the address, it sees the first bit, it sees it's set to a 0, it says Class A address. Terrific. Let's carry that on for a Class B. Okay, how are we going to tell a computer that this is a Class B address? Well, we can't put a 0 in the first bit position, because if we do, that means it's a Class A. So we're going to have to set the first bit to a 1, it's the only other option we've got, and we'll set the second bit to a 0. And therefore, if the first 2 bits are set to a 1 followed by a 0, then the computer can read those bits and say, okay, I get this. This is a Class B address, therefore the first 16 bits should be considered as network, and the last 16 bits should be considered as host. Let's follow that along then for a Class C. We can't put a 0 in the first bit position, because that would mean it's a Class A. We can't put a 0 in the second bit position, because that would mean it's a Class B. So we have to put the 0 in the third bit position. So if the first 3 bits are set 1, 1, 0 with a 0 in the third bit position, that means it's a Class C address, 24 bits network, 8 bits host. And I guess you can imagine what we do for a Class D. A Class D, a multicast address, is essentially the 0 in the 4th bit position, and so on. So if we are forced to put a 0 in the first bit position for a Class A, let's have a look at the possible range or ranges of networks that we've got available to us. We can go from all 0s in the first 8 bits to a 0 followed by all 1s. We can't do anything about the first 0, that's set, that says that this is a Class A. And if we now convert those into decimal, you now see that we've got a range of network addresses from 0 decimal up to 127 decimal. In other words, we've lost a whole bunch of our network addresses. We've lost 128 of our network addresses. So we've only got 128 left from 0 to 127. However, we're going to reserve a couple of those. We're going to reserve the first one with a 0 in the first, all 8 bits set to 0. And we're going to reserve that for future use. In actual fact, in the original days, that was the broadcast address. An address, anything sent to 0.0.0.0 was sent to the broadcast address in IP. We're also going to reserve the last one. That's 0 followed by 7 1s. That's 127 decimal. We're going to use that as a test address or loopback address. You may well know that if you ping or test an address like this is 127.0.0.1, you're actually pinging yourself. So you're testing your own local protocol stack. What that means is, with those 2 taken away, we have the available range on the Class A, range of addresses, of from 1 to 126. So we've got 126 Class A networks, but that's helpful to us. It means that whenever you see an IP address which starts from anywhere between 1 and 126, it's a Class A address, and that means that the first 8 bits are network and all the rest of the address is host. Okay, how about Class B then? Well, remember, with a Class B, the first 2 bits are set in stone. In other words, the first bit has to be a 1, the second bit a 0. So let's do the same thing with the Class B address. First octet again ranges from 10 followed by 6 zeros. In other words, convert that into decimal, we get a number like 128. And it ranges right up to 10 followed by 6 1s. So everything in between is an available Class B address. And if we convert those into decimal, you see we get a range of 128 to 191 decimal. So again, that helps us, because it means that when we look at an IP address and the first octet is set anywhere between 128 and 191, we look at a Class B address, and that means that the first 16 bits should be considered the piece of wire, and the last 16 bits are considered host space. Okay, same thing with the Class C. Remember, this time the first 3 bits are set in stone. 110, we can't do anything about that. So that gives us a possible range of 110 followed by 5 zeros, all the way up to 110 followed by 5 ones. Convert that back into decimal, we get a range from 192 to 223. Just one more, we'll do a Class D address. Class D address, the first 4 bits are set to 1 and the 5th bit is set to 0. And that gives us possible ranges, sorry, the first 3 bits are set to 1 and the 4th bit is set to 0. So that gives us a possible range of 1110 followed by 4 zeros, all the way up to 1110 followed by 4 ones. And if we convert those into decimal, you can see that the possible ranges of Class D addresses, multicast addresses, are from 224 up to 239. So this is helpful to us. It means that whenever we see an address, an IP address, you can look at the first number, the first octet, and tell whether it's a Class A, Class B, Class C, or Class D address. Okay, so let's just put all that together. What we're going to do is take a little network here. We've got a couple of bits of wire, a couple of Ethernet segments, and we're going to connect them via a router. And we'll put an IP address on each side of the router. On the left-hand side, we're going to put an address of 192.168.1.1. And on the right-hand side, we're going to put an address of 10.1.1.1. The router will look at those addresses, look at the most significant bits, look at what we consider to be the 192 portion of the address. It sees 110 and says, aha, I get this Class C address, therefore the first 3 octets, the 192.168.1.0 part of the address, is the network, and the rest is host space. On the other side of the router, on Ethernet 1 there, it looks at the address, it sees the first bit set to 0, says, okay, I get this is a Class A address, therefore the first 8 bits should be considered network, and the last 24 bits should be considered host. So what it puts in its routing table is this. It says, okay, I have 2 networks connected to me. Remember, routers are only interested in the wires, they're not interested in hosts sitting on those wires. So the router says, okay, I get this. I've got a Class C address, 192.168.1.0 on Ethernet 0, and I've got a Class A address, 10.0.0.0 on Ethernet 1. Now, if we try pinging between the 2 networks from one of the hosts to another, it all works. Okay, that's the end of part 2. Part 3 comes next, subnetting. We'll have a look at how subnets work. Stay with us, log into part 3.